Good day. We are here to present our project here, and it's called Real-Time Sign Language Entrepreneur for Online Video Chat. So due to health issue, two of our teammates cannot participate in this presentation. So here presenting with 94 ID Rashid of Oktam, 98 it's me, Mahmoud of Nurullah, 99 Rafshan of Azbek, and 86 Rasul of Sherzad. Okay. And introduction. Since sign language is usually primary tongue of many deaf people and those who was written language to be second, that's why conversation of the sign language to text would be helpful for communication with those who don't speak it. With this fifth growth of the development and telecommunications system and AI techniques, the use of sign language interpreter can be implemented in the real-time video conferences. The accuracy of AI recognition in our application mostly relies on video quality of a camera from user and fast internet connection. The application basically receives sign of gestures from video frames and transforms it to text and send it to other side of connection. The main scope of the data set we used for training is based on images of ACL, alphabets, A to Z, and couple signs. And value creation objectives. Okay, video chat application which can communicate to users with video stream from multiple sources. In this application, we will try to implement AI functionality to detect and translate sign language for people with disabilities. We choose this application type because in current situation related to pandemic urge for distant communication for different purposes emerged. Now everybody use application like Zoom or Skype for study to get online lectures or sessions from schools and universities. Most companies are moving to work from home strategy to keep employers and consumers safe and healthy. We see that these applications made life easier and for most people, but minorities with disabilities still do not have such platforms to use with comfort. This is why we decided to implement video chat application to help these people enjoy comfortable application with great experience for both traditional way of communication and with signs.
Excellent.
And my teammate Sherzad will slide further. Sherzad.
So hello, my name is Sherzad and I will continue. So talking about the cycling, so problem, first of all, I will start from the problem definition. Inability of people with disabilities having conversation, lectures, or interactive sessions with others, normally without inconveniences. This often requires a special person who knows sign language to translate all the sentences to both languages, or it takes huge resources and time to explain everything by text. So secondly, the data collection. The program will collect data from open sources, such as researching universities, databases. There are a lot of video recordings of people using sign language in front of computer. Also, session itself using program to be used for training. Then this data set can be split up into several groups. For example, training, validation, and test set. As we have a huge data set from university databases that are recorded from the different angles with separated cameras, and so we can separate them and use them to train our AI model. With the help of the online meeting using this program and different camera angle records, the model can improve its precision by having different use the same signs. And lastly, the evaluation. After training the model with data from multiple open source videos, we can be ready to evaluate the model using benchmark dataset. This evaluation shows which model precise enough to be suitable for deployment. So the next slide. In our sign language and gestures or image.
Previous slide.
Yeah.
Can you just describe this slide, Sherzad?
Okay. Therefore, the image sets and video will be divided in categories or particular sign gestures. The video or sets of images can be filmed in several scenes, namely front, side, and top. Each gesture is stored in its category or specific label. For instance, there can be a folder of thousands of frames or images of a sign representing letter A. So in this table illustrates all types of data processing techniques. Real-time data processing is the process of taking action on data in a short time period.
Yeah, next slide.
Okay, next slide. So the process is done as the data is inputted, so it needs a continuous stream of input data in order to provide a continuous output. In addition, the processing needs good establishment of multiprocessing to parallelize the process to get an output faster. With the help of different data discovery tools, we will filter the video file to detect both hands positions and detect the sign. So that's the end of my part, and my partner Aziz will continue.
Next slide.
Yeah.
Next. Next.
Okay, my name is Aziz, and I want to speak about our machine learning. And we must say who are the potential users and of our application. Firstly, people who have difficulty speaking and hearing. And so since the virus hits our civilization, our interactions with one another have changed dramatically. First, we needed to get away from each other, which hosted the popularity of video chatting apps like Zoom and Google Hangouts. People with various disabilities, on the other hand, are the most vulnerable members of our society. People with hearing and speech implementations are the focus of our application. And this is the architecture of our video conference application. And firstly, we say data acquisition and collection part of this architecture, the American Sign Language Standard, which provides small image labeled as word that reflect the sign, is our primary data source for trained data. And following model training, we will complete the frames that will be generated by laptops and run through our model. The second part is data processing, and it will be contain cleaning, normalization, and transformation will commence after the data has been collected. And to feed our model, we must convert each video into captions. The third step is the learning algorithm is to detect the client's hands. Following that, we must categorize the image captions based on whether one of two hands were utilized. We can oversee learning algorithms because our data is tagged. And the next is when the model has completed training on the training set data, it will enter the execution phase. On the test data will put our model to the test. Depending on the results, we will fine-tune the characteristics of our model. And it's a design of our implementation with the deep learning algorithm will be two very popular types of deep neural network. First is convolutional neural network, and the second is recurrent neural network. So we are going to take a look through of them and see pros and cons for our application. Okay, about the figure 6, deep learning. The next slide, please. This here you can see the CNN of our application. It will convey in the name means that the network use special kind of linear operations instead of matrix multiplication, at least one of its layers. The next. And there you can see the figure of RNN. It's a network recurrent in nature as it performs the same function for every input of data, while the output of the current input depends on the compilation of past one. So as it is seen obviously, CNN is perfect match of our case, and it will be good application of CNN, our classification, object detection, and semantic segmentation. So logically, both classification and object detection can be used in our project. That's all.
Next slide. Okay, let's talk about end-to-end design and implementation. To design model for our application, we did some analysis to choose suitable approach. As we need to translate the video stream frame by frame, we need to use OpenCV library and Keras library, as it is a tool that makes working with image and text data easier, simplifying the coding necessary for writing deep neural network code. Firstly, we are importing all the required libraries which are needed for our project as shown in this figure 8. Yeah, can you move that next slide? Yeah. As you can see, figure 10, we start with creating a training data set from the open source data set that is already labeled. We will use NumPy to address the image, and after collecting all data in one array, we will shuffle with help of shuffle function in random library. Next slide. Okay, next slide. Figure 12 shape of data set. Yeah. After the process is completed, we can see that all data was loaded and shuffled successfully. Moreover, we can see length and shape of the data sets. Figure 13, model training. Yeah, training the model to be able to classify all the sign characters in our data set. As you can see, first we are using 2 convolutional layers with 32 and 44 filters. Filter size is 3 to 3. Padding is same. After that, we are pulling the input, reducing dimensionality, and having 2 other convolutional layers. This time with 64 and 128. No, 128 filters correspondingly. And pulling again, we will repeat this procedure one more time. And at the end, we will flatten the feature map and drop out to prevent overfitting. And in fully connected layer, we are applying softmax activation function, which will output dimensional vector as number of classes we have. So next slide, please. Yeah, that's good. So in this figure, we can see that we have reached accuracy of approximately 99% from our model. I think this is impressive. Next slide, please. Yeah, yes. Yeah, with regard to figure 16, its parameters. We are declaring some parameters that is needed for our application to work. These are containers that we need to record and process recognized sign and size of region of interest. Okay, we start main part of our application as we feed frames of video to our model. We will grab every frame to wearable frame. Then we convert it to grayscale image as our model is trained with grayscale images. Then we need to specify the region of interest which will be cut and fed to the model to be predicted. So yeah, with regard to conclusion, I want to say that the objective of our project was to create an application that would help people with acute hearing implement our speech disabilities to communicate using a sign language with everybody. The received image is analyzed, processed, and converted to textual information. This project helped us to acquire available knowledge of convolutional neural network and how they identify and predict the solutions. During tests carried out on data test, our system approached to approximately 99% accuracy. Yeah, that's all. Thank you.